And now in this lecture we'll answer on two questions. In the first question we'll find out the radius of this quarter circle. In the second question we'll find out the size of this angle, angle theta, that is inside triangle ABC. Okay, so we'll start with the first question. In the drawing we have a quarter circle. Line segment BC equals to 9 units in its length. Line segment CD equals to 16 units. Line segment DL equals to 12 units. This angle OBC or CBO equals to 90 degrees. Angle BCD equals to 90 degrees. And this angle CDL is also equals to 90 degrees. And our mission is to find out the radius of this quarter circle. So because of the fact that this is a quarter circle, point O must be the center of the quarter circle. And write it down. Point O is the center of the quarter circle. And this angle BOF equals to 90 degrees. And finally, side AO must be equal to side OF, and both sides are the radii of the quarter circle. So we'll define the radius of this quarter circle as R. Therefore, side OA is equal to R, and side OF it is also equals to R. Okay, so those three things is true in any quarter circle. Okay, so in the next step we will extend the straight line CD by a straight line until it touches the radius OF. And we will define the touching point of the extended straight line CD and OF as M. So by doing this construction, actually we created here quadrilateral BCOM. I'll write it down. We have quadrilateral BCOM. And actually inside quadrilateral BCOM we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 degrees times 3 is 270 degrees, plus the size of the fourth angle, that's the actual angle DMO. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we will subtract 270 degrees from this equation, and we get that the missing angle DMO is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So this angle equals to 90 degrees. This is the right angle. So actually, we found out that inside quadrilateral BCOM, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle because it has 4 right angles. Repeat again. Quadrilateral BCOM is a rectangle, and we know that the opposite sides of a rectangle are equal to each other, so the opposite sides of rectangle BCOM must be equal to each other. That is to say, side BC must be equal to side OM. Side BC must be equal to side OM. Okay, side BC must be equal to side OM. But according to what is given as the question, side BC equals to 9 units. So we can write here that BC equals to 9. And for this equation, 9 equals to BC equals to OM. We will derive that side OM is also equals to 9 units. Here side OM equals to 9 units. It is given as the question that CD is a straight line. Then we extended the straight line CD by a straight line and we got line segment CM. And when you extend the straight line by a straight line, the result must be a straight line. So when we extended the straight line CD by a straight line, we got line segment CM. Therefore, line segment CM must be a straight line. So we write here that CM is a straight line. Okay, CM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is a straight line. So if we focus on the upper side of the straight line CD at point O, the sum of the angles according to this rule number 3 must be equal to 180 degrees. That is to say, which angles we have on the upper side of point, on the upper side of the straight line CD at point O, we have here angle alpha plus beta. Therefore, alpha plus beta must be equal to 180 degrees. Actually, we can implement rule number 3 number going. We know that CM is a straight line, so if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at this side of CM at point D? We have here 90 degrees. So I write it down, 90 degrees plus the size of this angle that is actually angle LDM. 90 degrees plus the size of angle LDM. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. I repeat again. 90 degrees plus angle LDM must be equal to 180 degrees according to rule number 3. Here we'll subtract from this equation 90 degrees and we get that the missing angle LDM is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So we found out that the missing angle LDM it is equal to 90 degrees. It is a right angle. This angle, it is a right angle, it is equal to 90 degrees. Likewise, we know that OF is the radius of this quarter circle. So OF as the radius of the quarter circle, it is absolutely a straight line. Okay, so we can write down that OF is a straight line. OF is a straight line. So if we focus on the upper side of the straight line OF at point M, the sum of the angles here must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of OF at point M? We have this angle that is equal to 90 degrees plus angle DMF. 90 degrees plus the size of angle DMF, in total they must be equal to 180 degrees according to rule number 3. I'll repeat again. On the upper side of OF at point M, 90 degrees plus the size of angle DMF, in total they must be equal to 180 degrees according to rule number 3. Here we subtract 90 degrees from this equation and we get that the missing angle DMF is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So I found out that this angle, it is a right angle, it is equal to 90 degrees. In the next step we will do a construction from point L. We'll draw a straight line on the radius OF. I repeat again, from point L we'll draw a perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point L and OF as point N. Actually, by doing this construction, we created here quadrilateral DLMN. And inside quadrilateral DLMN, we have 1, 2, 3 right angles. I repeat again, inside quadrilateral DLMN, we have 1, 2, 3 right angles. And the sum of right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DLN. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay? Here this equation expresses the fact that the sum of the angles in triangle DLMN equals to 360 degrees. Here we subtract 270 degrees from this equation and we get that the missing angle DLN is equal to 360 degrees minus 270 degrees. It is equal to 90 degrees. So it is actually a right angle. This angle, it is a right angle. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral DLMN as a rectangle. And write it down. Quadrilateral DLMN is a rectangle because it has 4 right angles. Okay. And we know that the opposite sides of a rectangle are equal to each other. Here we'll define side DM of quadrilateral DLMN as h. Side DM equals to h according to our definition. So inside quadrilateral inside the rectangle DLMN, we know that its opposite sides must be equal to each other. So here in rectangle DLMN, side DL, side DM, this side must be equal to side LN. Side DM must be equal to side LN according to the rule that the opposite sides of a rectangle are equal to each other. DL must be equal to LN, but according to our definition, DM equals to H. So you can write here that DM equals to H. And from this equation, H equals to DM equals to LN, we will derive that side LN is also equals to H. Here side LN equals to H. Okay. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that side DL in rectangle DLMN, side DL must be equal to side MN. DL must be equal to side MN. I repeat again, side DL must be equal to side MN according to the same rule. But according to what is given as the question, side DL equals to 12 units. So we can write here that DL equals to 12 units. And from this equation, 12 equals to DL equals to MN. We will derive that side MN is also equals to 12 units. Side MN equals to 12 units. So here actually you can see that ON, line segment ON equals to 9 plus 12, that is 21. And the radius of the quarter circle is OF. And here points N and F are very close to each other. Therefore we are expecting that the radius of this quarter circle will be a little bit longer than 21 units. Okay, so in the next step we will join points O and C together by a straight line. Point O is the center of the quarter circle. Point C is the point of the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of this quarter circle that is equal to R according to our definition. In the next step, we will implement the Pythagoras theorem on the right green triangle, triangle COM. And here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So by PT is by Pythagoras theorem. Expression for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right green triangle, triangle COM, the hypotenuse is CO, therefore the square of the hypotenuse is CO square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to OM square plus CM square. I repeat again, in the right green triangle, triangle COM, according to the Pythagoras theorem, CO square must be equal to OM square plus CM square. Okay. CO is the radius of the quarter circle that is equal to R, so CO square will be equal to R square, and it is equal to OM square. OM equals to 9, therefore OM square equals to 9 square, that is 81, plus CM square. CM, what is the length of line segment CM or side CM? CM equals to CD plus DM. That is to say CM equals to CD, that is 16, plus DM, that is H. So in total, CM equals to 16 plus H. If CM equals to 16 plus H, CM square equals to 16 plus H square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 16 plus H square. Here we will open the brackets on this side of equation number 2, of equation number 1, and we'll get that according to equation number 1, R square equals to 81 plus 16 plus H square. 16 square is 256 plus H square plus 2 times 16 is 32 times H is 32H. So in conclusion, we found out that R square equals to 81 plus 256 plus H square plus 32H. So actually, according to equation number 1, we found out that R square equals to 81 plus 256 is 337 plus H square plus 32H. In the next step, we'll join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is a point on the quarter circle itself. This is exactly the definition of a radius. That is to say, OL is the radius of the quarter circle that is equal to R. Okay. In the next step, we'll implement the Pythagoras theorem on the right orange triangle, triangle ONL. In the right orange triangle, triangle ONL, by PT is the version for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. the hypotenuse is OL, therefore the square of the hypotenuse is OL squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to ln squared plus ON squared. So in conclusion, we found out that in the right orange triangle ONL, OL squared equals to ln squared plus ON squared. OL equals to R, therefore OL squared equals to R squared is the radius of the quarter circle, and it is equal to ln squared. Ln is h, therefore ln squared is h squared plus ON squared. ON equals to OM plus MF, that is to say ON equals to OM, that is 9, plus MF, that is 12. So 9 plus 12 is 21. So ON equals to 21, therefore ON squared equals to 21 squared. So in conclusion, found out that according to equation number 1, according to equation number 2, R squared equals to H squared plus 21 squared. 21 squared is 441, so I write it down. So I found out that according to equation number 2, R squared equals to H squared plus 21 squared, it is 441. So here we actually have two different expressions for R squared. Therefore we create equation number 3 that states that R squared according to equation number 1 must be equal to R squared according to equation number 2. Okay? So R squared according to equation number 1 equals to 337 plus H squared plus 32H, and it must be equal to R squared according to equation number 2, that is equal actually to H squared plus 441. Okay, so here we have H squared on both sides of equation number 3, therefore H squared will get cancelled. What is left from equation number 3 after we cancelled H squared? Here in this side we have 337 plus 32H, that is equal to 441. Here we subtract 337 from this equation number 3, and we get that according to equation number 3, 32H equals to 441 minus 337 is 104. So in conclusion, found out that according to equation number 3, 32H equals to 104. Here we divide this equation number 3 by 32, and we get that H equals to 104 over 32. That is to say H equals to 3.25 units. So I found out that H equals to 3.25 units. In the next step we will substitute H in equation number 2 by 3.25 units that we found here. So according to equation number 2, we found out that R squared is equal to H squared plus 441. So here, according to equation number 2, R squared equals to 441 plus H squared. H equals to 3.25, therefore H squared will be equal to 3.25 squared, that is 10.56 5. So here we have r square that is equal to 441 plus 10.5625. It is 451.5625. Here we take a root out of this equation number 2, and we will get that the radius r of the quarter circle, it is equal to the square root of 451.5625. That is actually 21.25 units. Okay, so actually found out that the radius of the quarter circle that we are looking for, it is equal to 21.25 units. That is to say, it is a little bit longer than ON, that is equal to 21 units. Actually, the radius is longer, and then the line segment ON is 0.25 units. Okay, so the radius of this quarter circle equals to 21.25 units. We finish with the first question. In the next step, I will present to you the second question, and we'll solve the second question in two different methods. In the drawing, we have triangle ABC, angle AC equals to 40 degrees, angle ADC equals to 80 degrees, side AC equals to Y units, side DC equals to X units, side AB equals to X plus Y units, and our mission is to find out the size of this angle, angle theta, that is equal actually to angle ABC. Okay, we start with the first method. In the first method, we'll do a construction. We'll extend side BC in Y units. We extend side BC by a straight line in Y units. We define this point as point E. So here, line segment CE equals to Y units according to our construction. In the next step, we join points A and E together by a straight line. By joining the points A and E by a straight line, we created here triangle ACE. So I'll copy triangle ACE in a new page, and we'll analyze triangle ACE. So actually, this is triangle ACE that I copied from the original drawing. Angle AC equals to Y units according to what is given as the side AC equals to Y units according to what is given as the equation. Side C equals to Y units according to our construction. Those two sides are both equal to Y, therefore they are equal to each other. So here, side AC equals to side CE, both sides are equal to Y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. In front of side CE, we have this angle that is actually angle CAE. In front of this side, side AC, we have this angle, it is actually angle AEC. And according to the rule that I mentioned, those two angles must be equal to each other. So angle CAE must be equal to angle AEC because of the fact that they are located in front of equal sides. So if we define angle ACE as alpha, angle CAE equals to alpha, according to our definition, then from this equation alpha equals to angle CAE equals to angle AEC, we will derive that angle AEC is also equals to alpha. This angle is also equals to alpha. So in the next step we will copy angle ACB, this angle ACB in this triangle from the original drawing. So this is angle ACB, this is a copy from the original drawing. And we know that angle ACB equals to 40 degrees according to what is given as the equation. Here angle ACB equals to 40 degrees. And we have here the exterior angle theorem. So what is the exterior angle theorem? The exterior angle theorem is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC. In triangle ABC, this is angle alpha. This angle is equal to beta, and this angle equals to gamma. Angles alpha, beta, and gamma, they are defined as an interior angles. While this angle ACD, this angle is defined as an exterior angle. I write it down. Angle ACD is defined as an exterior angle. Why? Because it is located outside triangle ABC. We define angle ACD as E, so angle ACD equals to E according to our definition. So what is the size of the exterior angle E? According to the exterior angle theorem, the size of angle E, it is equals to the sum of the two interior angles that are not adjacent to it. Here angle gamma is adjacent to angle E, and the two other interior angles that are not adjacent to it are angles alpha and beta, and the sum of angles alpha and beta is alpha plus beta. So in conclusion, we found out that the size of angle E according to the exterior angle theorem, it is equal to alpha plus beta. I repeat again, the size of the exterior angle E in triangle ABC is equal to alpha plus beta. Is equal to the sum of the two interior angles that are not adjacent to it, that is actually alpha plus beta. Here we will implement the exterior angle theorem in our triangle ACE. In this triangle ACE, the two angles alpha and alpha are defined as an interior angles, because they are located inside triangle ACE, while angle ACB, this angle, is defined as an exterior angle. Angle ACB is defined as an exterior angle. Okay? And according to the exterior angle theorem, we get that the size of this angle ACB, it is equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to angle ACB. The two other angles that are not adjacent to angle ACB are those two angles. And the sum of them is alpha plus alpha. So in conclusion, we found out that angle ACB equals to alpha plus alpha. Okay? According to the external angle theorem, angle ACB, the external angle ACB is equal to alpha plus alpha. That is actually 2 alpha. But it is giving us the equation that angle ACB equals to 40 degrees. So we can write here that angle ACB equals to 40 degrees. And from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha equals to 2 alpha. We'll conclude that 40 degrees equals to 2 alpha. Here we divide this equation by 2 and we get that angle alpha equals to 40 degrees over 2, that is 20 degrees. So we found out that angle alpha equals to 20 degrees. Here we will write down that this angle equals to 40 degrees, to 20 degrees is equal to 20 degrees, and here alpha also equals to 20 degrees. So here angle CAE equals to alpha, that is equal to 20 degrees, and this angle CEA, this angle that is also equal to alpha, it is equal to 20 degrees. Okay, so here if we focus on triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees, 80 degrees plus 40 degrees is 120 degrees, so this angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees, that is the sum of the angles in triangle ADC. Okay, so this angle must be equal to 60 degrees. In the next step, I will copy triangle ADE in a new page and we will analyze triangle ADE. Okay. Angle DAE equals to 60 degrees plus 20 degrees, it is 80 degrees. Angle ADE equals to 80 degrees according to what is given us in the question. So this is triangle ADE that I copied from the original drawing. And what is the size of side DE? Here, you can see from the original drawing that DE equals to DC plus CE. Again, DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. In total, DE equals to X plus Y. So you can write down that here that DE equals to X plus Y. In triangle ADE, those two angles, they are equal to each other because they are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, there are equal sides. So in front of this angle, we have side DE. In front of this angle, we have side AE. And according to the rule that I mentioned, those two sides that are located in front of equal angles, they must be equal to each other. So side DE equals to side AE. But according to what we already found out, that DE equals to X plus Y. So you can write down that DE equals to X plus Y. And from this equation, X plus Y equals to DE equals to AE, we will derive that AE is also equals to x plus y. AE equals to x plus y. In the next step, I'll copy triangle ABE, the big triangle ABE, in this page, and we'll analyze triangle ABE. Side AB equals to x plus y, according to what is given as the question. This angle equals to theta according to what is given as the question. This angle equals to 20 degrees according to what we have already found out. And side AE equals to x plus y, according to what we have already found out just right now. So here AE equals to x plus y. So those two, this is triangle ABE that they call it from the original drawing. Those two sides are both equal to x plus y, therefore they are equal to each other. So side AB equals to side AE, they are both equal to x plus y, therefore they are equal to each other. And according to the rule that in front of equal sides in the triangle there are equal angles, we get that in front of side AB we have this angle that is equal to 20 degrees. In front of this side, side AE, we have this angle that is equal to theta. And those two angles must be equal to each other because of the fact that they are located in front of equal sides. Here, side AB equals to side AE. That is to say, we found out that angle theta equals to 20 degrees in its size. Okay, this angle theta equals to 20 degrees. So we finished with the first question. We finished with the first method. In the next step, I will present to you the second method to find out the value of this angle theta. So we'll focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So this angle must be equal to 60 degrees because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in this triangle. Okay. We define side AD as A. In the next step, I will present to you the law of sines and we will implement the law of sines in triangle ADC and also in triangle ABD. So what is the law of sines? The law of sines is true in any triangle. So here we have triangle ABC that could be any triangle. This is triangle ABC. Side BC equals to A units in its length, angle BAC equals to capital A in its size, side AC equals to B units in its length, angle ABC equals to capital B in its size, capital B degrees in its size, and finally here side AB equals to 3 units in its length, and angle ACB equals to capital C degrees in its size. In this triangle ABC, according to the law of sines, you get that A over sine A equals to B over sine B equals to C over sine C. Okay. Repeat again, in this triangle ABC, that could be any triangle, A over sine A equals to B over sine B equals to C over sine C. Now we will implement the law of sines in the green triangle ADC. So in the green triangle ADC, according to the law of sines, we get that AD over sinus 80 degrees equals to DC over sinus 60 degrees and it is also equals to AD over sinus 40 degrees. I repeat again. In the green triangle ADC, according to the law of sines, AD over sinus 80 degrees equals to DC over sinus 60 degrees equals to AC over, it is actually, here we have AC. Here it is AC over sinus 80 degrees. I'll repeat again. AC over sinus 80 degrees equals to DC over sinus 60 degrees, and it is equals to AC, it is equal to AD, it is equal to AD over sinus 40 degrees. So I'll repeat again. According to the law of sines in the green triangle ADC, AC over sinus 80 degrees equals to DC over sinus 60 degrees, and it is equal to AD over sinus 40 degrees. So question number 1 is the implementation of the law of sines in the green triangle ADC. Here AC equals to Y, so we'll substitute AC by Y, and we'll get that Y over sinus 80 degrees equals to DC equals to X, so we'll substitute DC by X, and we get that it is equal to X over sinus 60 degrees, and it is equal to AD. AD is A, so we substitute AD by A, and we get that it is A over sinus 40 degrees. So according to equation number 1, we found out that y over sinus 80 degrees equals to x over sinus 60 degrees equals to a over sinus 40 degrees. So those three expressions are equal to each other, so we can define them as they are all equal to k. Yeah, they are all equal to each other, so we can define them that they are all equal to k. And here we derive the first equation. Those two expressions are equal to each other. So the first equation will be y over sinus 80 degrees. It is equal to k. Here we multiply this equation number 1 by sinus 80 degrees. And we'll get that according to equation number 1, y equals to k times sinus 80 degrees. So we found out that according to equation number 1, y equals to k times sinus 80 degrees. We will derive the second equation from this longer equation. Those two expressions are equal to each other, that is to say x over sinus 60 degrees is equal to k. Here we'll multiply this equation number 2 by sinus 60 degrees, and we get that according to equation number 2, x equals to k times sinus 60 degrees. Okay. So we found out that x equals to k times sinus 60 degrees. And finally, those two expressions are also equal to each other. So we create equation number 3 that states that a over sinus 40 degrees is equal to k. According to equation number 3, a over sinus 40 degrees is equal to k. Here we multiply this equation number 3 by sinus 40 degrees, and we will get that according to equation number 3, a equals to k times sinus 40 degrees. So we have the values of a, x, and y in 3 equations. In the next step, we will implement the law of sines in triangle ADB. With the on triangle ADB, but before that, we'll find out the size of angle ADB. ABC is a triangle, therefore side BC is one side of triangle ABC, and BC is the side of a triangle. It is absolutely a straight line. So if you focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. So so here we have which angles we have on the upper side of BC at point D. We have here 90 degrees plus this angle. and the sum of those two angles must be equal to 180 degrees. So this angle equals to 80 degrees, so this angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of the straight line BC to 180 degrees. This angle must be equal to 100 degrees. Now we will implement the law of sines in the orange triangle, triangle ABD. So in the orange triangle, triangle ABD, according to the law of sines, we will get that AD over sinus theta AD over sinus theta equals to AB over sinus 100 degrees. I'll repeat again. Here, equation number 2 is the implementation of the law of sines in the orange triangle, triangle ABD. And according to the law of sines in the orange triangle, triangle ABD, AD over sinus theta equals to AB over sinus 100 degrees. Okay? So here, AD equals to A, therefore we'll substitute AD by A and we'll get that A over sinus theta equals to AB. AB equals to x plus y, so we substitute AB by x plus y and we get that x plus y over sinus 100 degrees equals to A over sinus theta. So in conclusion, we found out that again A over sinus theta equals to x plus y over sinus 100 degrees. In the next step, we'll substitute A by K times sinus 40 degrees. We'll substitute X by K times sinus 60 degrees, and we substitute Y by K times sinus 80 degrees. So we'll do it now. We'll get that according to equation number 2. So A equals to K times sinus 40 degrees over sinus theta equals to x plus y over sinus 100 degrees. X equals to K times sinus 60 degrees and y equals to K times sinus 80 degrees, all divided by sinus 100 degrees. So in this equation, equation number 2, we have K on both sides of the equation, so K will get cancelled. What is left from equation number 2 after we cancelled K? What is left is that in this side of the equation we have left only with sinus 40 degrees over sinus theta, that is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation, equation number 2, and we get that according to equation number 2. Sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Here we will divide this equation number 2, by sinus 60 degrees plus sinus 80 degrees, and we will get that sinus theta is equal to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. Okay, we have the trigonometric identity that sinus 2a equals to 2 sine A cosine A we will use this trigonometric identity for sinus 40 degrees. Sinus 40 degrees is equals to sinus 2 times 20 degrees, and according to this trigonometric identity that sinus 2a equals to sinus 2 sine A cosine A, we'll get that sinus 2 times 20 degrees will be equal to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees is equal to 2 times sinus 20 degrees times cosine 20 degrees. So we can substitute sinus 40 degrees in equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. We'll do it later. First of all, I will present to you the second trigonometric identity. And the second trigonometric identity is sinus 100 degrees plus theta, that is equal to cosine theta. Okay, we will use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees is equal to sinus 90 degrees plus 10 degrees, and according to this trigonometric identity that sinus 90 degrees plus theta equals to cosine theta, we will get that sinus 90 degrees plus 10 degrees will be equal to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees. You can also substitute sinus 100 degrees for cosine 10 degrees in equation number 2, and you also substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees. So we'll do it now, and we get that according to equation number 2, sinus theta equals to sinus 40 degrees, but we already found out that sinus 40 degrees is 2 times sinus 20 degrees times cosine 20 degrees, and we have to multiply it by sinus 100 degrees, but we have already found out that sinus 100 degrees equals to cosine 10 degrees, so we'll substitute sinus 100 degrees by cosine 10 degrees, and we have to divide it by sinus 80 degrees plus sinus 60 degrees. So here we have another trigonometric identity that we'll use the following trigonometric identity for the value of sinus 80 degrees plus sinus 60 degrees. The trigonometric identity states that sinus D plus sinus C is equal to 2 times sinus D plus C over 2 times cosine D minus C over 2. We'll use this trigonometric identity for sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus D plus C. D is 80, C is 60, so D plus C is 80 plus 60, this is 140, and 140 over 2 is 70 degrees, times cosine D minus C. D minus C is 80 minus 60, that is 20, and 20 over 2 is 10. Okay, so in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We'll do it now, we'll get that in equation number 2. So we'll do it now, we'll get that according to equation number 2. Sinus theta is equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sinus 80 degrees plus sinus 60 degrees, but we just right now found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. So we substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. And we also have 2 in the numerator, 2 in the denominator, so 2 also will get cancelled. What is left from equation number 2 after we cancel the 2 expressions? What is left is, in this side of the equation we have sinus theta, that is equals to sinus 20 degrees times cosine 20 degrees, all divided by sinus 70 degrees. And we have the last trigonometric identity, that sinus 90 degrees minus theta equals to cosine theta. We will use this trigonometric identity for sinus 70 degrees. Here, sinus 70 degrees is equals to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we will get that sinus 90 degrees minus 20 degrees is equal to cosine 20 degrees. So in conclusion, we found out that sinus 70 degrees is equal to cosine 20 degrees. Therefore, we will substitute sinus 70 degrees in equation number 2 by cosine 20 degrees, and we will get that according to equation number 2, we found out that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, but we just right now found out that sinus 70 degrees equals to cosine 20 degrees, therefore we substitute sinus 70 degrees by cosine 20 degrees in this equation, equation number 2. So here we have cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled, and we're left only with sinus theta that is equal to sinus 20 degrees. And we know we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So here if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees, of the size of angle theta is 20 degrees. So we finish with the second method. In the next step, I will summarize the lecture. We'll start with the first question, of course. In the drawing, we have a quarter circle. 9 segment BC equals to 9 units, 9 segment CD equals to 16 units, 9 segment DL equals to 12 units, and our mission is to find out the radius of this quarter circle. First of all, because of the fact that this is a quarter circle, we can conclude from it that point O is the center of the quarter circle. This angle BOM equals to 90 degrees. And finally, we also can conclude from the fact that this is a quarter circle that side AO equals to side OF, and both sides are the radii of this quarter circle. So we define the radius of this quarter circle as R, therefore AO equals to R, and OF it is also equals to R. They are both the radii of this quarter circle. In the next step, we actually extended the straight line CD by straight line, and we define the touching point of the extended straight line CD and OF as point M. In this way, we created quadrilateral BCOM. In quadrilateral BCOM, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees plus the size of the fourth angle, that is angle DMO. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and we found out that the missing angle DMO equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So this angle equals to 90 degrees, it is a right angle. So we actually found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle because it has 4 right angles. And we know that the opposite sides of a rectangle are equal to each other. So in rectangle BCOM, side BC must be equal to side OM. BC equals to OM, but it is given as the equation that BC equals to 9 units. Here BC equals to 9, and from this equation 9 equals to BC equals to OM, we will derive that OM is also equals to 9 units. Here OM is also equals to 9 units. Then we actually know it is given us the equation that CD is a straight line, and when we extended the straight line CD by a straight line, the result is CM. And when you extend a straight line by a straight line, the result must be a straight line. So the result that is CM must be a straight line. So CM is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have in this side of CM at point D? We have this angle that is equal to 90 degrees plus this angle that is angle LTM. In total, the sum of those two angles must be equal to 180 degrees. So 90 degrees plus angle LTM must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and found out that the missing angle LDM equals to 180 degrees minus 90 degrees, it is 90 degrees. Okay, so this angle equals to 90 degrees. Likewise, we know that OF, it is the radius of the quarter circle, therefore it is absolutely a straight line. OF as a radius of the quarter circle must be a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have in the upper side of OF at point M? This angle equals 90 degrees. Plus this angle, that is angle DMF, in total they must be equal to 180 degrees. Repeat again, here 90 degrees plus angle DMF must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and we found out that the missing angle DMF equals to 180 degrees minus 20 degrees, it is equal to 90 degrees. So this angle equals to 90 degrees. In the next step, we did a construction from point L. We drew perpendicular on the radius OF. Repeat again, from point L, we drew perpendicular on the radius OF. So this angle equals to 90 degrees according to our construction. Okay, we define the touching point of the perpendicular from point L and OF as N. So in this way, we actually created quadrilateral LDMN. By doing this construction, we created quadrilateral LDMN, and inside quadrilateral LDMN, we have 1, 2 for right angles. Again, inside quadrilateral LDMN, we have 1, 2 free right angles. And the sum of free right angles is 90 times 3 is 270 degrees. So 270 degrees plus the size of this angle, that is actually angle DLN. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 360 degrees, we subtracted 270 degrees from this equation, and found out that the missing angle DLN equals to 90 degrees. So this angle equals to 90 degrees, it is a right angle. So we found out that inside quadrilateral DLMN, we have 4 right angles. And any quadrilateral that has 4 right angles, must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. Why? Because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. So, but before that, DM, side DM equals to h according to our definition. So, and according to all the opposite sides of a rectangle are equal to each other. So in rectangle DLMN, side DM must be equal to side LN. Side DM must be equal to side LN. But according to our definition, side DM equals to h. So from this equation, h equals to DM equals to ln, we will derive that side ln is also equals to h. Here, side ln equals to h. Likewise, according to the same rule, that the opposite sides of rectangle are equal to each other, we'll get that in rectangle DLMN, side DL must be equal to side MN. Here, side DL must be equal to side MN. But according to what is given as the equation, side DL equals to 12. So we can write here that DL equals to 12. And from this equation, 12 equals to DL equals to MN, we will derive that side MN is also equals to 12 units. Here, side MN is also equals to 12 units. Okay? So, in the next step, we join actually points C and O together by straight line. Here, point O is the center of the quarter circle. Point C is the point of the quarter circle itself. Therefore, CO is the radius of the quarter circle that is equal to R. We implemented the Pythagoras theorem on the right triangle, triangle COM. According to the Pythagoras theorem, CO square, the square of the hypotenuse equals to the sum of the source of the perpendiculars. That is to say, CO square equals to CM square plus MO square. In the right triangle, triangle COM, CO square equals to OM square plus CM square. Here, CO equals to R, therefore CO square is R square. OM equals to 8, therefore OM square is 8 square, that is 81, plus CM square. CM equals to 16 plus 8, therefore CM square is 16 plus 8 square. So in conclusion, we found out that according to equation number 1, R square equals to 81 plus 8 plus 16 plus 8 square. Here we open the brackets on this side of equation number 1 and found out that according to equation number 1, R square equals to 81 plus 16 plus 8 square. 16 square is 256 plus 8 square plus 2 times 16 is 32 and 32 times 8 is 32h. So according to equation number 1, we found out that R square equals to 81 plus 256 plus 8 square plus 32h. 81 plus 256 is 337. So in conclusion, we found out that according to equation number 1, R square equals to 337 plus h square plus 32h. In the next step, we join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore, OL is the radius of the quarter circle that is equal to R according to our definition. Then we implemented the Pythagoras theorem on the right triangle, the right orange triangle, triangle OLN. According to the Pythagoras theorem, OL square equals to LN square plus ON square. I repeat again, according to the Pythagoras theorem on the right orange triangle, triangle ONL, OL square equals to LN square plus NO square. So here, OL equals to R, therefore OL square is R square. Ln equals to h, therefore ln square is h square. And NO equals to 9 plus 12, that is 21, therefore NO square equals to 21 square. So in conclusion, we found out that R square equals to h square plus 21 square. 21 square is 441. So in conclusion, according to equation number 2, we found out that R square equals to h square plus 441. So here we have two different expressions for R square. Therefore, we created equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. R square according to equation number 1 is 337 plus h square plus 32h, and it must be equal to R square according to equation number 2, that is h square plus 441. Here we have h square on both sides of the equation, so h square will get cancelled. And what is left from equation number 3 after we cancel h square? What is left is, in this side we have 337 plus 32h equals to 441. Here we subtracted 337 from this equation, equation number 3, and found out that Here 32h equals to 441 minus 337 is 104. So according to equation number 3, we found out that 32h equals to 104. Here we divided this equation number 3 by 32 and found out that h equals to 104 over 32, that is 3.25. Then we substituted h by 3.25 in equation number 2. According to equation number 2, r squared equals to h squared plus 441. So, and h equals to 3.25, therefore h squared will be equal to 3.25 squared. That is 10.5625. So in conclusion, according to equation number 2, we found out that r squared equals to 441 plus 10.5625, and 441 plus 10.5625 equals to 451.5625. Here we took a root out of this equation number 2, and we found out that the square root of 451.5625, it is equal to 21.25 units. Okay, so the radius of this quarter circle, it is equal to 21.25 units. That is a little bit greater than the length of ON, that is 21. It is greater than ON in 0.25 units. Okay, so we finished with the first question. Then I presented to you the second question, and we solved the second question in two different methods. So here in the drawing we have triangle ABC. Angle ADC equals to 40 degrees, angle ADC equals to 80 degrees. Side AC equals to y, side DC equals to x, side AB equals to x plus y, and our mission is to find out the size of this angle and theta. In the first method, we did the construction, we extended side BC in y units. That is to say, C equals to y. Then then we joined points A and D together and created triangle ACE. Then I copied triangle ACE in a new page and analyzed triangle ACE. So this is triangle ACE. This is triangle ACE that I copied from the original drawing. Side C equals to y according to construction, and side AC equals to y according to what is given as the question. Those two sides, they are both equal to y, therefore they are equal to each other. So side AC equals to side CE equals to y. And we have the rule that in front of equal sides in the triangle, there are equal angles. So in front of this side, we have this angle, in front of this side we have this angle, so those two angles must be equal to each other because of the fact that they are located in front of equal sides. That is to say, angle CAE must be equal to angle AC. So if we define one angle as alpha, then the other angle must be also equal to alpha. So those two angles, they are both equal to alpha. Then I copied triangle ACB from the original drawing. We know that triangle ACB equals to 40 degrees according to what is given as the question. Then I presented to you the external angle theorem. According to the external angle theorem, that is true in any triangle. If this is triangle ABC, and this triangle ABC, this angle equals to alpha, this angle equals to beta, this angle equals to gamma. Those three angles are defined as interior angles because they are located inside triangle ABC. While this angle ACD that is located outside triangle ABC is defined as an exterior angle. So we defined angle ACD SE, so the exterior angle ACD equals to E according to our definition, and the size of the exterior angle ACD, it will be equal to the sum of the two interior angles that are not adjacent to it. Angle gamma is adjacent to angle ACD or to angle E, therefore the two other interior angles that are not adjacent to it are alpha and beta. Therefore the size of the interior angle E equals to alpha plus beta. Then we implemented the exterior angle theorem in our triangle ACE. Here those two angles alpha and alpha are defined as an exterior angles because they are located inside triangle ACE, while this angle ACB is defined as an exterior angle. So the size of the exterior angle ACB will be equal, according to the exterior angle theorem, to the sum of the two interior angles that are not adjacent to it. And the two interior angles that are not adjacent to it are those two angles that are alpha and alpha. That is to say, angle ACB equals to alpha plus alpha in its size. Alpha plus alpha is 2 alpha. So we found out that angle ACB equals to 2 alpha according to exterior angle theorem. But it is given us the question that angle ACB equals to 40 degrees. So we can write here that angle ACB equals to 40 degrees. And from this normal equation, we can derive that 40 degrees equals to 2 alpha. We divided this equation by 2 and found out that angle alpha equals to 20 degrees. So here angle alpha equals to 20 degrees. And here in the original drawing, this angle is alpha, therefore it is equal to 20 degrees. And this angle is also alpha, therefore it is also equal to 20 degrees. Then we focus on triangle ADC. So actually here, in triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. 40 degrees plus 80 degrees is 120 degrees. So if two angles equals to 120 degrees, the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in triangle ADC. Okay, so this angle equals to 60 degrees. Then I copied triangle ADE in a new page and we analyze triangle ADE. This is triangle ADE that I copied from the original drawing. This angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. What is the size of side DE? DE equals to DC plus CE. That is to say, DE equals to DC, that is X, plus CE, that is Y. So DE equals to X plus Y. DE equals to X plus Y. So those two angles are equal to each other in triangle ADE, and we have the rule that in front of equal angles in the triangle there are equal sides. So in front of this angle we have side DE, in front of this angle we have side AE. Therefore those two sides that are located in front of equal angles must be equal to each other. That is to say, DE must be equal to AE. But according to what we have already found out, DE equals to X plus Y. So from this equation we will derive that AE is also equals to X plus Y. AE equals to X plus Y. Then I copied triangle ABAE in this new page and we analyze triangle ABE. Side AB equals to X plus Y according to what is given as the equation. This angle equals to theta according to what is given as the equation. This angle equals to 20 degrees according to what we have already found out, that alpha equals to 20 degrees. And we just right now found out that A equals to X plus Y. So here, this is an associated triangle because side AB equals to X plus Y and side AE is also equals to X plus Y. That is to say, those two sides are both equal to X plus Y, therefore they are equal to each other. So side AB equals to side AE. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of this side AB we have angle that is equal to 20 degrees. In front of this side AE we have this angle that is equal to theta. And those two angles must be equal to each other. Why? Because they are located in front of equal sides. That is to say, angle theta equals to 20 degrees. This angle theta equals to 20 degrees. So we finished with the first method. Then I presented to you the second method. In the second method, we focused on triangle ADC. In triangle ADC, this angle equals to 80 degrees. This angle equals to 40 degrees. 80 degrees plus 40 degrees is 120 degrees. So if two angles in a triangle is equal to 100, if the sum of two angles in the triangle is 120 degrees, the third angle must be equal to 60 degrees. Why? Because 60 degrees plus 120 degrees is 180 degrees, and the sum of the angles in any triangle is equal to 180 degrees. Okay, so this angle equals to 60 degrees. Then we define side AD as A, and then I presented to you the law of sines. The law of sines is true in any triangle, so this is triangle ABC that could be any triangle. in triangle ABC, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay? Then we implemented the law of sines in the green triangle, triangle ADC. In the green triangle, triangle ADC, AC, this is AC over sinus 80 degrees equals to DC over sinus 60 degrees equals to AD over sinus 40 degrees according to the law of sines. I repeat again that the question number 1 is the implementation of the law of sines in the green triangle, triangle ADC. Okay? So here AC equals to Y, therefore we substitute AC by Y. DC equals to X, therefore we substituted DC by X, and AD equals to A, therefore we substituted AD by A, and we got this equation number 1. So those three expressions are equal to each other, therefore we can define all of them as K. Okay, each of them is equal to K because they are equal to each other. Then we derive the first equation. Those two expressions are equal to each other. That is to say, y over sinus 80 degrees equals to k. We multiply this equation by sinus 80 degrees and found out that y equals to k times sinus 80 degrees. Then we derive the second equation. Those two expressions are also equal to each other. That is to say, x over sinus 60 degrees equals to k. We multiply this equation by sinus 60 degrees and found out that x equals to k times sinus 60 degrees. And finally, those two expressions are also equal to each other. That is to say, according to equation number 3, a over sinus 40 degrees equals to k. We multiply this equation number 3 by sinus 40 degrees and found out that a equals to k times sinus 40 degrees. So we have three different expressions for a, x and y. Then here BC is a straight line because it's one side of triangle ABC. So if we focus on the upper side of the straight line BC at point D, here the sum of the angles here must be equal to 180 degrees. So which angles we have on the upper side of BC at point D? This angle equals to 80 degrees plus this angle. This angle must be equal to 100 degrees in order to complete the sum of the angles on the upper side of BC at point D to 180 degrees. This angle must be equal to 100 degrees. Then we implemented the law of sines in the orange triangle, triangle ABD. According to the law of sines, in the orange triangle, triangle ABD, AD over sinus theta equals to AB over sinus 100 degrees. I repeat again, in the orange triangle, triangle ABD, according to the law of sines, AD over sinus theta equals to AB over sinus 100 degrees. AD equals to A, AB equals to x plus y. So we substitute AD by A and AB by x plus y. Here, AB equals to x plus y and AD equals to A. And we got this equation, A over sinus theta equals to x plus y over sinus 100 degrees. A equals to k times sinus 40 degrees, so we substitute A by k times sinus 40 degrees. X equals to k times sinus 60 degrees, therefore we substitute x by k times sinus 60 degrees. Y equals to k times sinus 80 degrees, therefore we substitute y by k times sinus 40 degrees, and we got this equation. Here we have k on both sides of the equation, so k will get cancelled. What is left from equation number 2 after the cancelled k? What is left is that according to equation number 2, sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2 and found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Here we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees and we found out that according to equation number 2, sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees times sinus 60 degrees. This is actually equation number 2. Then we have presented to you the trigonometric identity that sinus 2a equals to 2 sine a cosine a. We use this trigonometric identity for the value of sinus 40 degrees. Sinus 40 degrees is sinus 2 times 20 degrees, and according to this trigonometric identity, that sinus 2a equals to 2 sine a cosine a, we will get that sinus 2 times 20 degrees equals to 2 times sine 20 degrees times cosine 20 degrees. Okay? So here in conclusion, found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Therefore, we can substitute sinus 40 degrees in equation number 2 by 2 times sinus 20 degrees times cosine 20 degrees. But before that, I presented to you the second trigonometric identity. And according to the second trigonometric identity, we have sinus 90 degrees plus theta equals to cosine theta. We use this trigonometric identity for sinus 100 degrees. Sinus 100 degrees is sinus 90 degrees plus 10 degrees. And sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. According to this trigonometric identity, that sinus 90 degrees plus theta equals to cosine theta. Therefore, sinus 90 degrees plus 10 degrees will be equal to cosine 10 degrees according to this trigonometric identity. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, and sinus 40 degrees equals to 2 times sine 20 degrees times cosine 20 degrees. So here we have sinus 80 degrees. According to equation number 2, sinus theta equals to sinus 40 degrees, and we substituted sinus 40 degrees by 2 times sine 20 degrees times cosine 20 degrees, and we substituted cosine 100 degrees by cosine 10 degrees. So in conclusion, we found out that sinus theta equals to 2 times sinus 20 degrees cosine 20 degrees times cosine 10 degrees over sinus 80 degrees plus sinus 60 degrees. Here we have a trigonometric identity for the value of sinus 80 degrees plus sinus 60 degrees. The trigonometric identity states that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. So according to this trigonometric identity, sinus 80 degrees plus sinus 60 degrees will be equal to 2 times sinus d plus c over 2. D is 80, c is 60, so d plus c is 80 plus 60, that is 140, and 140 over 2 is 70. So it is 70 degrees times cosine d minus c over 2. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. We did it, and we got that in equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees. In the denominator, we add sinus 60 degrees plus sinus 80 degrees. Therefore, we substituted it by 2 times sinus 70 degrees times cosine 10 degrees. And we got this equation. We have cosine 10 degrees in the numerator, cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will also get cancelled. And we what is left from equation number 2 of them cancel those two expressions. What is left is that sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. We have the last trigonometric identity that sinus 90 degrees minus theta equals to cosine theta. We use this trigonometric identity for sinus 70 degrees. Sinus 70 degrees is equal to sinus 90 degrees minus 20 degrees. And according to this trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we will get that sinus 90 degrees minus 20 degrees equals to cosine 20 degrees. Therefore, in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. Therefore, we can substitute sinus 70 degrees in equation number 2 by cosine 20 degrees. We did it, and we got here that according to equation number 2, sinus theta sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees, and we substitute sinus 70 degrees by cosine 20 degrees. So here we have cosine 20 degrees in the numerator and cosine 20 degrees in the denominator. So cosine 20 degrees will get cancelled, and we're left only with sinus theta that is equal to sinus 20 degrees. And we have the trigonometric identity that if sinus alpha equals to sinus beta, then it means that alpha equals to beta. So if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the size of this angle theta, is equal to 20 degrees. Okay, thank you very much.